Okay, so just to recap, we have actually covered the distinct linear factors. So remember the different ones, like this and this. Okay, then we also covered the case of repeated linear factors, so like this kind. Okay, and the last thing we're going to look at is called the irreducible quadratic factor. Okay, so what does irreducible mean? It means cannot be factorized further or cannot be simplified further lah. Yeah. Okay, quadratic just means the degree is 2. Okay, so you realize it's x squared plus c squared, right? Okay, so the thing is, right, examples of this include x squared plus 1 or x squared plus 3, etc. Okay, but you realize it has to be plus because if you have a case of x squared minus 1, we know that this can be further reduced to x plus 1, x minus 1. Okay, so it has to be x squared plus c squared in order for it to be considered as the third case. Okay, so let's go back to the question 5. Okay, so you can fill up the quadratic in your notes. Okay, so for a denominator with an irreducible quadratic factor x squared plus c squared, we write the partial fraction as this. Okay, so before that you realize we always write it as a over the factor plus b over the factor, etc. But you see that because this one, right, is a quadratic. Okay, so how you can remember it is because it's a quadratic, right, the on top we want it to be like a linear expression. Okay, so that's why it has to be ax plus b. Okay, so if you look again, let me just show you again. Okay, you realize that, okay, this is just to help you remember. Okay, so you see that, okay, inside here this is still a linear, right? Okay, these are linear. Okay, but you realize this is a quadratic expression. Okay, so because it's quadratic, so you can remember it as the top the numerator part will has to be a linear, which is ax plus b. Okay, so let's go to the question 5. Okay, let's look at question 5. They ask you to express x squared minus x plus 10 over x plus 1, x squared plus 3 in partial fractions. Okay, so once again we do the same thing. First thing we do is to check that it is a proper fraction. So the degree is 2, the degree is 3. Okay, remember this is degree 2, this is degree 1, so they add up to degree 3. Okay, so no issues with this. So let's start it proper. It will be let x squared minus x plus 10 over x plus 1, x squared plus 3. Okay, so remember the first part is the distinct linear factor, right? This one. Okay, so we'll have a over x plus 1 first, and then the second one is going to be bx plus c x squared plus 3. Okay, so ultimately just take note that there will be two unknowns lah. It's a linear factor, so one unknown will be the coefficient of x and the other one will be the constant. Okay, so now we have these 3, and next thing we do, of course, is the same thing. We multiply throughout by the denominator. Okay, so what we'll get is x squared minus x plus 10 equals to a x squared plus 3 and then plus bx plus c x plus 1. Okay, please remember your brackets here. Okay, because I'm multiplying the two expressions. Okay, so now comes the substituting the values that will remove certain variables. Okay, so the first obvious one that we can use is this one. So we sub x equals to -1. So -1 squared minus -1 plus 10 equals to a -1 squared plus 3, and then plus b -1 plus c, and then -1 plus 1. Okay, so we know this entire part will just be 0. Okay, so what we're left with is -1 squared is 1. 1 plus 1 plus 10, this will be 1 plus 3 is 4a. So we know for A is going to be 12 and A is going to be 3. Okay, so now we have this already. Then the next part is what other values can we sub? So you see that we don't exactly have any other factors that we can sub in. If you look at here, okay, there's no value of x that we can sub in such that this entire thing becomes 0. Okay, but you realize, okay, actually I can sub x to be 0 here, because when x is 0, the b becomes nothing because it disappears, because it's 0 times b is 0. Okay, so next thing we can do is to sub x equals 0. So 0 square minus 0 plus 10 equals to a 0 plus 3. So 0 square plus 3 plus b 0 plus c 0 plus 1. Okay, so we have 10 equals to 3a, and then this is plus c 1. Okay, c times 1. So we know that a is also 3, so we have 10 equals to 3 times 3 plus c. Okay, so finally we know that c will just be 1, which is 10 minus 9. Okay, so now we got a and c already, and we got no other possible values to sub, so we just need to sub a random value. Okay, so we can just sub 1. So we need to find a random value to sub. Okay, so we found a random value to sub. So of course we take the easier numbers, which is in this case 1. So 1 square minus 1 plus 10 equals to a 1 square plus 3 plus b 1 plus c, and then 1 plus 1. Okay, so 1 minus 1, 0, 10. This will be 4a plus b plus c, 2. Okay, so we can sub in our values of a and c. Okay, so this is what we'll get. And then finally we know that your 2b plus 1 is equals to 10 minus 12, which is negative 2. Okay, and then b plus 1 is going to be negative 2 divided by 2 is negative 1, and then b is going to be negative 2. Okay, so now we have our a, b, and c value. We just need to put it back in. So we just copy back the question. X squared minus x plus 10 over x plus 1, x squared plus 3. Okay, this will be equals to a, which is 3 over x plus 1, and then the bx plus c, right? So we have plus negative 2x plus 1 over x squared plus 3. Okay, so this will be the final answer. Okay, so once again, there are very similar methods, similar steps as before, but I think one thing new is to take note of this. Okay, the fact that subbing in x equals 0 eliminates b. Okay, other than that, then this is the random value that you sub in, and once you have the 3 values, you just need to put it back into the original expression here. Okay, and remember that we need to put in this formula, okay, because of the irreducible quadratic factor. Okay, so this is for question 5. Okay, please make sure you try to digest the information. Make sure you take it down also, and take down the notes that I've written here. So, okay, then we will look at question 6 in class.